Hey everybody, welcome back to Math Pastor. In the third part of this series on factors, fractions, and exponents, we're going to talk about equivalent fractions. In this video, there are three terms you need to make sure you know: fraction, equivalent fraction, and then simplest form of a fraction. Those terms we'll define as we go through. First, fraction. What's a fraction? Well, a lot of people are fearful of fractions. They look at fractions, they freeze up, or they just get this anger inside of them because fractions have caused them some distress in the past. Well, listen to this because it's important. Fractions aren't as bad as people think they are. I always joke around and say that fractions are more natural than decimals because I've never heard a young kid ask for 0.5 of a candy bar when they're asking to share something. They always ask for half of it. Half is a fraction. So fractions are more natural than decimals, and actually they're easier to use as long as we know how. So let's check this out. A fraction, first, is just a relationship of two numbers by division. That's all it is. It's a division problem. So the top is called the numerator, the bottom is called the denominator, and we are dividing the top by the bottom. Fractions are typically less than 1, but you can have fractions that are more than 1 as well. The term for that's improper fraction. But the top divided by the bottom is what we're talking about. So 1 divided by 2 is just 1/2. 3 divided by 4 is just 3/4. So as we think about fractions, it's just a relationship between two numbers by division. That's all it is. Now, equivalent fractions are fractions that represent the same value. Now, I know that sounds strange because why wouldn't you just say 1/2 and 1/2? But if you have a container that's marked by fourths or quarters, 2 of those quarters is the same as the container that's marked by halves and 1/2. So sometimes I use circles to do this. Some people call them circles or pizzas or pies, and pizzas are good things to think about with fractions because they're often sliced into fractions. Although, if you're watching this around lunchtime or dinner time, that might make you more hungry, and I apologize for that. So, as we look at these circles, this first circle on the left is cut in half. The circle on the right is cut in fourths. The circle farther to the right is cut in eighths. Now, when we look at this, if we shade one part of the first circle, that's half of the circle. It's one part out of two parts. That's the fraction 1/2. Excuse me. If we look at the middle circle and we shade the same portion of the circle, what we notice is 2 pieces are shaded in. So 2 pieces are shaded out of the total 4 pieces we have, so 2/4. If we look at the third circle, the one to the farthest right, we see that to shade the same amount of the circle, we must shade 4 pieces of that pizza, because 4 pieces is half of that pizza. So the first circle is the fraction 1/2, the second circle is the fraction 2/4, and the third circle is the fraction 4/8. All of these represent the same amount of the circle, so that makes these fractions all equivalent fractions. All right, so equivalent fractions are two fractions that represent the same value or the same amount. Now, to see if two fractions are equivalent, you could always draw circles, cut them up into pieces, fill up those pieces, and see if they represent the same portion of the circle. But that's not really convenient. That's also going to take up a lot of paper, and it's hard to draw circles always the same size. So that becomes a challenge. So one way we can make sure that we check if two fractions are equivalent is to see if they can be divided by the same value to get to the same fraction. So think back to our example that we just looked at. 4/8, 2/4, and 1/2. Let's look at 2/4 for a moment. If I divide the numerator and the denominator by the same value, in other words, I can find the greatest common factor of 2 and 4, which is 2, and then divide by that greatest common factor, I end up with the same fraction that I have on the left. So 2 divided by 2 is 1, 4 divided by 2 is 2, so 2/4 becomes 1/2. So 2/4 is equal to 1/2 because they can be reduced to the same exact fraction. Hey, let's move over to the right a little bit and look at 4/8. What's the greatest common factor between 4 and 8? Well, the greatest common factor between 4 and 8 is 4. 4 divided by 4 is 1. 8 divided by 4 is 2. So 4/8 also becomes 1/2. So what we can see is when we divide the numerator and denominator by the same values, we can eventually get to the same exact fraction of 1/2. This is called simplifying fractions, or fractions in the simplest form. So when we simplify fractions, if we can divide the numerator and the denominator by the same value, that fraction that results is equal to the fraction that we started with. Let me say that as a definition. Are you ready for this? If you want to take notes, this is one of those parts that you want to take notes. So fractions are equivalent fractions if they can be reduced to the same exact fraction, the same exact numerator and denominator. All right, so check this out. We're going to talk about simplifying fractions now. So simplifying fractions, because that's kind of what we just did. We just used easy fractions to do it. So let's talk about this. We can simplify a fraction if the numerator and denominator share a greatest common factor greater than 1. So if the greatest common factor of the numerator and denominator is more than 1, we can reduce that fraction. So let me say that in a different way. And here we go. This is a definition you can write down if you want in your notes. A fraction can be simplified as long as the numerator and denominator are not relatively prime. Remember from our last video, relatively prime means the greatest common factor they have is 1. So if the numerator and denominator are not relatively prime, if they have a greatest common factor more than 1, it can be simplified. And you can keep simplifying it until they are relatively prime. Once they are relatively prime, then you have the simplest form of that fraction. So let's take this example for a moment. 25 over 30. What is the greatest common factor between 25 and 30? Well, the greatest common factor between 25 and 30 is 5. So if I divide numerator and denominator, the top and the bottom, if I divide them both by 5, the top, 25 divided by 5, is just 5. And the bottom, 30 divided by 5, is 6. So 25 over 30 is equivalent to 5 over 6. Now 5 over 6 do not share any common factors other than 1. So 5 over 6 is the simplest form of that fraction. That's how you reduce fractions or write the simplest form. All right, one final thing I want to tell you before we move on to our examples. So in a fraction, any fraction, you can multiply the top and bottom by the same number to get an equivalent fraction. So we just saw that with the simplifying fraction example we just did. We divided top and bottom by 5. So 25 over 30 became 5 over 6. But you can also multiply fractions. So 1/2 multiplied by 3 over 3. 1 times 3 is 3. 2 times 3 is 6. So 1/2 is equivalent to 3 over 6. In algebra, we would write it like this. If a and b are the numerator and denominator of a fraction, so a over b, I can multiply a and b by anything, and I have an equivalent fraction, as long as those things are the same. So a over b is the same as a times c over b times c. I know what you're thinking. Why would we start including letters in math? I mean, math is numbers. Well, if we can do it with letters, then we can do it with any number. So I can multiply top and bottom by the same value and get an equivalent fraction. I can divide top and bottom by the same number and get an equivalent fraction. And that's a rule we have in math. So that helps us find equivalent fractions, and it helps us simplify fractions. All right, here's our two examples. So our two examples we're going to look at today are, first, find equivalent fractions, and second, simplify fractions. Those are the two types of problems you'll face in this topic. So first, if we are given a fraction and we are told to find 3 equivalent fractions, I can multiply that fraction by any number over itself 3 different times to get 3 different fractions. So here's an example. I'm going to choose the weird fraction 3 over 7. 3 over 7 multiplied by 2 over 2 is 6 over 14. There's one equivalent fraction. Then the second one, 3 over 7, if I multiply it by 5 over 5, gives me 15 over 35. There's a second equivalent fraction. And then I can do 3 over 7 times 10 over 10, which is 30 over 70. These are 3 equivalent fractions to 3/7. Now I can use any number, so to this particular problem, there's an infinite number of correct answers, as long as they're always equal to 3 over 7. The second type of problem is to simplify fractions. And again, we did this with 5 over 6, but here's another example that we can use. So let's imagine for a moment the fraction 8 over 24. When we look at 8 and 24, we want to try to figure out what's the greatest common factor between 8 and 24. Well, we know 1 goes into each of them, 2 goes into both of them, 4 goes into both of them, but 8 is the biggest number that goes into both 8 and 24. So that's the number I'm going to use to divide numerator and denominator by. 8 divided by 8 is 1, and 24 divided by 8 is 3. So the fraction 8 over 24 simplifies completely to 1/3. All right, you should be ready to tackle any problem that deals with simplifying fractions or equivalent fractions. Good luck.